different PhD students center at this time, working in different subject topic areas. And today, I give you an outline for the presentation today. The first portion will give you in outlook for our activities of presentation study, including the modern study. And then the second portion of the presentation is how we can integrate ground observation and satellite measurement together. So include the climate type of activity, which we have one activity ongoing called the Persian climate data record, Precipitation climate data record for more than 30 years, and then also ongoing development. And then the final part is the bias adjustment using gauge information for the satellite estimation. So give case study of Chile as an example and give a conclusion after the result. So here is our system in the remote sensing, and here is the cloud in the development process, and then we look at the cloud, and then with the cloud top information and screening into different temperature level. And as you can see that, here. So this is a lifetime development from growing to the mature and then continuing. And from the satellite, just the top views of the structure from the test microwave. And then this is one view. This is mature connected stone, which has the kind of structure here. And then in our system, we put as a so-called object-based approach, which look at the system and segmentation process by looking at those connected structure into different pages. And then in each page then they have a express code of different temperature level, which is bringing the segment area into different portion, which the next level is to the classification of those objects into different raining categories. And for each of the category, and then they have a certain kind of rainfall properties according to the category and data to the training system. And this system has been developed over like more than 10 years and then continue evolving into the operational system. So UNESCO GWADI, IHP GWADI program, which has also adopted our system as part of the operation of the satellite precipitation measurement system. So you can go to our GWADI page here, that they have all kinds of different functions. So you can accumulate the rainfall into the, look at the from the current time, and also 2 to 3 hours to up to 72 hours before for the rainfall distribution and accumulation, and also have many different functions which we continue to update. We will give you a more detailed discussion and information about how we can take a look at more friendly way of looking at the precipitation distribution in different areas, and of success data and download looking at that. And here is the new developed system called iRAN. It's pretty much to show the same data set, but in a more friendly way. And in the training section, in the presentation by Kuo, he will give you a more detail of how you can success the data by looking at different regions, political division, river basin, or watershed, or linkage points, by looking at those different locations and zoom into and take a look at all the timing accumulation, given the animation views for the time period. So this is the current system right now, but going to talk about continued improvements for this system is ongoing on different directions. And the first one is, over highlighted regions, so we have more corrections using test microwave rainfall data, which is going right now. And then the second portion is the part is one cloud giving rain. The system might not be effective to capture the at this time, which we are also trying to do that part. And then extending to multiple.
Can you put the slide back?
Yes. This slide. Back one. This one. Is this slide you are looking for?
No, now the screen is back to you and cool. So we don't see the presentation. We don't see the
presentation. You cannot see the presentation, right?
Yes. Can you share it again?
Okay. All right. Share it again. Yes. Let's try it again. Can you see?
Yes, it's back on.
No.
Thank you.
It's back on now?
Yes.
Okay, good. So, okay, good. So the continued developments are in different directions. I will just go over quickly so we can get into the other parts. And the first portion is some correction of our estimates using PERSIANN microwave rainfall and its climatological corrections of different regions every 5 degree bucks. And overall, high latitude region has more corrections. So that's why we want to improve estimates on the high latitude region. And over the low and mid latitude region, the corrections are more limited. And this is one example to show you in one day before and after corrections. And the top one is the top one image here is the original estimates, and then the lower image is the one with has microwave correction, which you can see I circle several orange area that you can see the correction track the highlighted region rainfall smaller in general. And then for the warm cloud giving rain, this system we have threshold to extract the image, and we put the warm temperature to 253. But some of the warm cloud giving rain is much higher temperature than this threshold. So what we need to do is we have to improve, we have to improve warmer temperature clouds into our classification system, which we can make estimates for those warm cloud or warm rain cloud as well.
Sorry,
so this is one example.
Again, Professor Su. Now we lost your video.
Lost again?
Yeah.
Maybe I shouldn't touch the mouse. Yeah, maybe that's the problem. Yeah, okay. Can you see now?
Yes. Okay.
Okay,
we can see the whole.
all right. Good. So you see the map here on the right hand top. One is the radar image. So and then the cloud image in the long way infrared is the second one. And I use the circle to circle some the portion which is raining. And then the left hand side of the image is the estimate, but with different threshold temperature for classification. So you see the top one is 253 is now the current system. And then if we start to include the higher, warmer threshold, and some features start to show up for the rain. If I okay, good. So you are still with us, right? You see the image?
Yes, we can.
Okay, good. So I circle another portion which you will see the part is the more warm cloud, and then from the radar image in red. And then from the left hand side you will see the original system of 253 over the area like near Arizona has no rain, but the radar shows some rain. It's because of warm cloud, and that part is not under the coverage. However, when we raise the temperature threshold, the warm cloud noise under the coverage of the classification system, which the rain signature is also show up over the left hand, the bottom left hand corner for that particular unit. And then we also include different channels and observation. This is a hurricane event. And over the left-hand side, over the top corner is the radar image. In the green means rain, and the then white area is the no rain time. And we also test different channels and dimensions, and to see that how different combination of channels could include the detection of rain, which is in the green area of other boxes. Then the red side means overestimate, and then the blue means underestimate. Combination also help to improve the rainfall detection. And we also have a build model, the conceptual cloud model, and use a different cloud image in time tracking, and also has microwave corrections, which we do have couple papers also in that direction, also under development project. So the one I'm talking about is more to some continued developments over our system in our center here. And the next part is now moving from those kind of operations, now we get into the how can we provide the kind of data for hydrological studies or climate studies. So we have one product called the PERSIANN-CCS climate data record. And this one has provided the data record starting from the 83 to the current time, near current time. And the idea is we use geostationary satellite estimates, and in the past every 3 hours, the system gives one snapshot estimate, and of course accumulate to the daily total, and then continue to accumulate to the monthly total. And we use TPCP global precipitation planning program, the monthly precipitation as a reference, which that data set has gauge information over land, and then we compare the difference. At the same time, the bias is breaking it down to the temporal time scale, which to update the estimates over the short time. So at the end, the product available we generated every 3 hours is an estimate, but the product is sent to everybody from the National Climate Data Center of NOAA here for the degree and also daily scale. So this is one example to show you daily rainfall global coverage over a time like between rainfalls to Louisiana.
Sorry, we don't see the slide again. So if you don't see, I will
okay, yeah,
so
that will be
that will have
nice.
the signal. So I will interrupt your presentation.
Okay. So
okay, it's back.
okay.
Your
this is
might be yeah. Okay, we can see it.
oh, you see it? Okay, good.
Can you see the animation?
Can you see the animation?
Yes, we can see the animation.
Okay, good. So this is a product is provided daily and for the degree. Then here's some evaluation of product over East Asia gauges interpolated data. For the top one is the top 95% precipitation, and then the central one is the rainfall total for the rain over 10 millimeter, and then the bottom one is the rainy day for the rain over 10 millimeter. So this is a kind of statistic to show from the gauge as interpolated data of the East Asia, and then Persian CBI, our kind of data records in the comparison. And then every pixel time series is also plotted in the third column, which has a correlation. And then, of course, the scatter plot also provided by the last column. So on the third column, you can see over the eastern area, eastern region that the products to the gauge. Gauge has a lot of gauge over the eastern side, and they are really high correlation. And then to the western side, and gauge are potential limited, and then correlation is also is not necessarily consistent over the western side. And then the continued development is we use our high resolution algorithm now to extend to the historical record, so that this data potentially could be implemented at a high resolution of 0.04 degree, and then with a test microwave correction, and at the end also include the TPC corrections. And I give you one particular example to show you. This is one particular month of it's July of 2015, and the bottom one is monthly estimate at 2.5 degree by 2.5 degree on GPCP, and the top panel now is 0.04 degree by 0.04 degree from our current operation CHRS estimate. So include as microwave correction, and then also include the GPCP correction, and get into the middle panel, which is 0.04 degree. So you can see the change is getting to much higher resolution, and over the low latitude region, some changes depends on which area we are looking at. And over high latitude, you can also see that our product underestimate, but with the corrections, which make more closest to GPCP, but with higher resolution. And now we get into a particular short-term look, and this is one particular date of July 25th of 2015, and daily estimate provided over here with the correction